This time we're going to have a look at AQA GCSE Maths Foundation Tier, Paper 2 from November 2017. So Paper 2 is a calculator paper, and so we'll need one of these to hand, a calculator. So without further ado, let's get going and have a look at question number 1. There it is for calculator. Anyway, how many minutes are there in 2 1/4 hours? Now this question, I've seen a lot of people get it wrong with surprising frequency. I'm going to talk you through a few ways of thinking about it, but hopefully you should all know, I'm sure you all do know, that 1 hour is 60 minutes. And so that in itself tells us a conversion factor between hours and minutes. I'm going to return to that in a second. But if 1 hour is 60 minutes, then we can say that 2 hours will be double that, which is 2 times 60, which is 120 minutes. So for 2 hours, we've said that's 120 minutes. Now we need to think about what the other bit means. Quarter. Now, a quarter of an hour, if you're running a quarter of an hour late, that would mean you're running 15 minutes late. Another way of thinking about it is to find a quarter of something, you divide it into 4 bits, 4 pieces. And so 60 minutes, which is an hour, divided into 4, 60 divided by 4 is 15. And so 2 1/4 hours, 2 1/4 hours, is 120 minutes, plus 15 minutes for a quarter of an hour. 120 plus 15 comes to 135. So that's one we need to circle. The answer to this is 135. Excuse me. Now, I did mention about conversion factors. Going back to, as I said, 1 hour is 60 minutes. What we can do, because this ratio isn't a ratio of one number is 1, another number which isn't 1, to change from hours to minutes or from minutes to hours is simply going to be a case of multiplying or dividing by the number that isn't for 1. In this case, multiplying or dividing by 60. So to change from hours to minutes, from a small number to a big number, we can multiply the hours by 60. And going the other way around, from minutes to hours, going the opposite way around means doing the opposite thing. Instead of multiplying by 60, we'd be dividing by 60. But because we want to change from hours to minutes, what we could do here is type in 2 1/4 as a mixed number on the calculator. I'll show you how to do that now. Shift fraction button, type in 2 1/4 and multiply that by 60. Again, no surprise, we get 135. So a few different ways of mentioning that for question 1, but the overall answer we need to circle is 135. Question 2, which of these numbers is half of a square number? So we need to just remember what square numbers are. And so a square number just means a number, a whole number multiplied by itself. So we can do a list of square numbers here. The first one is 1 squared, which is 1. The second one is 2 squared, which means 2 multiplied by 2, which is 4. And 3 squared, which is 9, and so on and so on. 4 squared equals 16. Don't believe me, you can ask your calculator itself. For example, the squared button on a calculator is this one here. So 2 squared, which means 2 to the power 2. That will tell us that the answer is 4. Now, the question isn't asking us which one of those numbers is a square number. We want to be looking at which one of them is half of a square number. So if these numbers here are the square numbers, we need to be thinking of what's half of each of these numbers. Half's even in bold, so not much excuse if you read the question carefully. So if you half all of these numbers, and to half something means we're going to divide them by 2, we need to be looking for a number in this option of 4 which appears. So half of 1 is, well, obviously a half. 4 divided by 2 is 2. 9 divided by 2 is 4.5, or 4.5 if you prefer. And 16 divided by 2, half of 16 is 8. And so we found half of the square numbers by dividing them by 2, as I said. Which number is half of a square number which also appears in this list? The answer is 2. 2 is half of the square number, 2 is half of 4, and 4 is a square number. And so the one we need to circle this time round is the second option, which is 2. Question 3. Circle the value of the digit 3 in the number 17.03. And so I can explain in terms of tens and units, but I'll give you a quick way on a calculator first. So circle the value of the digit 3 means we're only interested in this number. So we don't really care about the other numbers, so for all we're bothered about, we can think of the other numbers as being 0. So change your 1 to a 0, change your 7 to a 0, keep that 0 as 0. Only thing we care about is that 3, which is 2 numbers after the decimal point. Now if you've got a decent enough calculator, like I've got here, not meaning to brag, 0.03, press equals, it will tell you that it's 3 out of 100. And so this is the one we need to circle. Another way you could have done this is by trying each of these and seeing what the answer would be on your calculator. So for example, 3 over 10, the first one, that's 0.3. Now that 3 is in a different position to the 3 here. 1 over 30, just go back and edit the number. That's 0.03, but that dot above it doesn't mean 3, that means 3 going on forever. So that's 0.0333, so that's not exactly the same either. But if you were to try them all, eventually you come to 3 over 100. What you'd find is you'd have a 3 in the exact same location, the exact same value. That 3 represents just 3, there's no dot above it. I did mention how I could show you using the idea of hundreds, tens and units, so I will do. So in terms of y, the answer is 3 over 100. Imagine the decimal point separating the whole parts of numbers from the fractional parts. The first number to the left of a decimal is units, and tens, then hundreds, and beyond hundreds it's thousands. And so each time we move to this side, after the decimal, what we're dealing with there is numbers which are 10 times bigger than the last. 10 times a unit is 10, 10 times 10 is 100, and so on. So going the other way, each digit to the right represents 10 times less than what it would have done if it were a digit to the left. So if we take a unit and divide it into 10, that tells that the first number after the decimal place is tenths, and 1/10 divided by 10, you can try this again on the calculator if you really wanted to, a tenth of 1/10 would be 100th. And so we have tenths, after tenths we have hundredths, and so on. So we have 300ths, which is this one here. So that's just going a bit more in depth as to why the answer is what it is. But long story short, we can just try in our calculator, take all the other numbers to be 0, leave the 3 as it is, press equals, and there you go. Question 4. The value of A is double the value of B. If we just write this down as it comes up in the question, the value of A is double. If we double something, it means we multiply by 2. Double the value of B, which is the same as saying A equals 2B, because with algebra we don't need the multiplication sign. So A equals 2 multiplied by B. If you just think of what the words mean and applying that to what it would be in maths language in algebra, the value of A is obviously just the letter A, is, in this case this means is the same as, and is in this case therefore the same as means equals. So A is the same as double, which means times in by 2, the value of B. And so if you just take your time and think it through, A is double the value of B, A equals 2B. And that's all there is to that one. Question 5, simplify y multiplied by y. Y times y is going to be y squared. You can imagine each y having an invisible 1 above its head. If a number or a letter doesn't have any power given, we can always assume that that power is an invisible 1. Now hopefully you'll remember when you're multiplying the letters or the numbers, if the base numbers or base letters are the same, in this case if they're both y's, we add the little numbers together. So the new power of y will be 1 plus 1, which is 2. Y times y is y squared. And 5 part B, simplify 5a plus 2 minus a plus 9. We've got two different things here to simplify down. The first thing we need to consider is the a's. So first we've got 5a, and we always look at the thing in front of a letter. The symbol in front of each letter tells us whether to consider it as a positive thing or a negative thing. So this a has a minus in front of it, and so that means it's a negative a. So 5a take away a would leave us with 4a. Now looking at the numbers, both numbers, the 2 and the 9, have plus signs in front of them. So they're both positive. So if we add 2 and then add 9, that's the same as adding together a total of 11, because 2 plus 9 is 11. And so our answer is 1 mark for 4a, 1 mark for positive 11, 2 marks having both. And that's question 5 done. Question 6, we've got a table showing information about birds in a garden, and we're asked to draw a bar chart to show this information. So what I'd suggest we do first of all is to put some axes on the graph. So that means an x-axis going along and a y-axis that goes up. Now the standard thing to do is to put frequency or totals on the y-axis and the things you're measuring going along on the x-axis. And so in this case, what we're wanting to be doing is the bars, which are the birds along x, and the height of the bars going up in y. So we also need to pick a scale as well. So what I'm going to suggest is that each one square is just worth 1 bird. I mean, it doesn't have to be that way, but I would suggest that's probably the easiest scale to pick, and being simple is better than making it complicated and possibly making mistakes. And so what we're going to do first of all is to complete the axes and label them. A big mistake of bar charts, or charts in general, is people not labeling the axes. So what we can do now is just label this. Start from 0 is easier. Go up in 1s, 2s, 3, 4, 5 and 6. So we can label this total number of birds, or something similar. You could just call it frequency if you wanted. That would have done the trick too. Total number of birds. And along at the bottom, what we need to do is do the bars. And so the first bar for the robin, for example, is 2. So we need to do a bar 2 high that represents the robin. And the sparrow, 5 sparrows are seen, so we do a bar going up which is 5 high. As well, the bar chart, it's very important that the bars are equally spaced. So each bar needs to be of equal width, and the gaps in between the bars need to be equal each time. So in this case, I think it's probably just easiest if you leave one square between each bar. Wrens, 3, so 3 high for the wrens, and lark, just 1 lark was seen. And so not only do we need to label each bar, so this one was robin, second bar was sparrows, third was wren, and the fourth was lark. We need to label what these are. People might not know what a wren or lark is, so label this something like species of bird or type of bird. Species will do. Species just means type of bird. So species of bird along the x-axis, and the y-axis shows us the total number of birds. And so the y-axis needs to go up on an even scale. In this case, each square represents 1 unit, or 1 bird. And the bars, as you can see, are all the same width, which is important. And each bar has a gap between each other of 1 square. And so that will do for question 6. Question 7, a bit of a problem-solving question, this one. It's about Eve and Ola, who both have coins. What we're told is that Eve gives 3 of her coins to Ola. After she gives those coins away, Ola has the same amount of money as Eve. What coins does Eve give to Ola? This is one of those questions where it can be quite tricky knowing where to start. And so what I would suggest we do, first of all, is to total up Eve's coins. What do they total up to? So if it's a calculator paper, safest bet I would suggest would be to use the calculator. So her first coin is a £2 coin, and plus a £1 coin, then plus 50p. Be careful how you type in 50 pence. It's not 50 quid, so don't type in 50. What I'd suggest is do 0.50, 2 lots of 20p, so 0.20 plus 0.20, a 5 pence next, which is 0.05, and finally a 2 pence coin, which is 0.02. And you should get a total of £3.97 for Eve. And Ola's coins, we can work out a total of these. £1 plus 50 pence plus 2 pence plus 1 pence. You can use a calculator if you want to. In fact, I'd probably suggest you do just to make sure. But check it again in your head. Just do it yourself, and you should see that it comes to £1.53. And so, after Eve gives 3 of her coins to Ola, they have the same amount of money. And so this amount of money after is divided between the 2 of them. So what we could do is calculate the total amount of money they both have. The total amount of money for both Eve and Ola is the value of Eve's coins, which comes to £3.97, plus the values of Ola's coins, which comes to £1.53. If we add these up together, what we should find is that the total amount of money they've got between them is 5.5, which is £5.50. Now it says after Eve gives some coins to Ola, she has the same amount of money as Eve. And so if they both have the same amount of money, what we can say is that the total amount of money is shared equally between them into two equal amounts. So we can divide this £5.50 by 2 to find out how much money they'd each have after Eve gives some coins away. So because you have the same amount of money, that's why we're dividing by 2. We're splitting it into two equal shares. £5.50 divided by 2, we should get £2.75. And so if we compare what Eve had, £3.97. She then ends up with £2.75. So we can work out how much money Eve must have given away by doing what Eve used to have, subtract from what she ends up with. The difference will tell us how much money Eve must have given away to Ola. And so £3.97, just move it over so you can see the calculation. £3.97 subtract £2.75 gives us a total of £1.22. And so from that, we can work out what coins she must have given away. So Eve gave away £1.22. So what 3 coins of Eve's, because there's 3 coins, remember, total £1.22. And what we should be able to see, hopefully fairly easily, is that that would be for £1 coin, one of the 20p coins, and a 2p coin, because £1 plus 20p plus 2p comes to £1.22. And so Eve must have given away £1, 20p, and a 2p. I'm going to show you a different method for this one as well. That, to me, I've just shown the method, is in my mind the most straightforward one, but I'll show you another method as well just in case, because this is quite a tricky question. So I'm just going to move on to another page to show you the second method I'm going to demonstrate. And this method I'm going to show you now is how you can sort of pair them up, Eve's money versus Ola's, so you can sort of see how they might have the same amount of money. So Eve got a £2 coin. Can we make Ola's amount match with that £2 by moving one of Eve's? So what you could do is move £1 from Eve and give it to Ola. And so what I've done here is I've just moved this £1. And so then you can say that, well, this coin is the same value as these 2 coins. They've both got a 50p, so let's leave the 50p. So £2 for Eve, £2 for Ola. 50p for Eve, 50p for Ola. Now, it seems uneven that Eve's got 2 20p and Ola has none. And so to me it seems almost obvious that surely we should have 1 20p each if we're going to have the same amount of money. So they'll both share out 1 20p. So I'm just going to highlight one of the 20p's, which means that that used to be Eve's. Now have a look at the remaining coins. Eve's got left a 5 and a 2, which is 7p. Ola's got a 1 and a 2, which is a 3p. So how can I make these two amounts equal? Well, 1 plus 2 plus 2 would be the same as that 5. And so what might be easiest to do is if I move this 2 of Eve's, and then what would happen is that those amounts of money would also now match up. So this 5p matches to this 5p. So in a way of sort of sectioning out the money, getting each coin to marry up to other coins, you can share it out, and it can be shared out in this way. So Eve must have given to Ola a £1, a 20p, and a 2 pence. So in my mind, that's a more complicated way of doing it, but it's just another example of how you may tackle it if you're really not sure what to do in the exam. Question 8. We've got a dry cleaning shop with different offers, and we're asked to work out the total price for 2 suits and 6 dresses. And so what I'd suggest we do is take the suits first, come to the dresses after. So the first suit is going to be normal price, which will be £12.50. And the deal here, it says the second suit is going to be half price. So the second suit will be half of £12.50. So £12.50 divided by 2. Let's just try that on our calculator. £6.25. And so, because we're only getting 2 suits, we can look up the total for the 2 suits now. So the total for the 2 suits is just the price of the first one plus the price for the second. So £12.50 plus £6.25 comes to £18.75. So let's just underline that, and we're done for the suits. Now we can move on and start thinking about the dresses. Now the dress offer is different to the suit offer. The dress offer says 3 for the price of 2. And so what this means is that for every 3 suits, sorry, not suits this time, for every 3 dresses you get, we're only going to actually pay for 2. So we're going to get 3 for the price of 2. But because we want 6 dresses, not just 3, we're going to use the offer twice. So we're going to get 3, only pay for 2, then get another 3, so we're going to get a total of 6. But actually, all we're going to be paying for is 4 dresses, because of this 3 for the price of 2 deal they have on. Tell if I could spell dress, that's embarrassing. Wake up, Sean. Right, dresses. 3 for the price of 2 means 6 for the price of 4, just like I've done in that little diagram there, that little table. 6 for the price of 4. Because obviously we want 6 dresses as it says, but because of this offer, we only need to pay for 4. And so the total cost of 4 dresses is 4, because we're getting 4, times 975, which you can work out easily enough with one of these machines called a calculator. 4 times 975, that's going to come to £39 exactly. So now we've got the total price of the dresses, and we've got the total price of the suits. So the total price is just simply going to be total price of the suits, which is £18.75, plus the total it was for the dresses, which is £39. So if we add these two totals together, whoops, wrong colour, £18.79 plus 39 So 39, just add on 1875. Same answer, just different order of writing it. You should get £57.75. 57.75. So that's what we need to write down on our answer line for our final answer. £57.75. Question 9. We're told Karl's got twin sisters and that the sum of the ages of Karl and his twin sisters is 39. In 4 years' time, the twins will be 18. How old will Karl be in 4 years' time? It's information overload of this question, but if you structure it out, it's not half as bad as what it may seem. And so we've got two time frames. We've got now, and we've got 4 years' time. And the key word here is twin sisters. Now, twins are always going to be the same age, plus or minus a few minutes, but will always be the same age. So what we can do here is sort of split it up into a table and just fill in the bits and pieces as they come up. And so it says here that the sum of ages of Karl and his twin sisters is 39. So altogether, Karl and his twin sisters' sum, means the total of their ages, is going to be 39. So we can fill this bit in. The total age of all of them right now is 39. It says in 4 years' time, the twins will be 18. So both his twin sisters will be 18 in 4 years' time. So we can say sister 1 will be 18 and sister 2 will be 18 because we've been told that. So just going to highlight this bit of information. And so we can work backwards. If in 4 years' time they'll be 18, right now they'll be 4 years younger than what they will be in 4 years' time. And so 18 take away 4 means that right now each sister must be 14 years old. So that in 4 years' time, yeah, they will be 18, but right now they're 14. And so the total of their ages right now is 39. And so both the sisters, when you add their ages together, 14 plus 14 is 28. And so Karl's age right now must be 39, take away each of his sisters' ages. So Karl right now must be 11 years old. As a double check, you could just try 11 plus 14 plus 14 and you'd get 39. And so the original question, how old will Karl be in 4 years' time? Well, if he's 11 now, in 4 years' time, he must be 15. And that's our final answer. So in 4 years' time, Karl is going to be 15 years old. That's our final answer for question 9. Question 10. 4 marks for putting down 4 different things. Each statement, 4 statements, we've got 3 different options. Either the statement must be true, the statement cannot be true, or it might be true. First one, I'm just going to have a look at the first statement. So the first statement is saying about the triangle being equilateral. I also want to have a look at the third statement, which is about the triangle being right-angled. If the only criterion we've got for this triangle is that one of its angles is 60. We're not told anything else at all about this triangle. We're not told about the other 2 angles. We're not told about any of the sides either. What we do need to remember though is that the angles in a triangle will always add up to 180 degrees. It's not that they sometimes do, or they probably do. They always do. That's one of the laws of triangles, if you like. Angles inside a triangle add up to 180 degrees all the time. And so what I've got first of all is one possible triangle we could have. And so if one of the angles is 60 degrees, if I look at the third statement, the triangle is right angled. Well, let's think about it. If one's 60 and a right angle's 90 degrees, so I'm just going to highlight here that right angle, just means 90 degrees. The other angle would have to be 180, take away 60, take away 90, which is 30. And so that's allowed. So it could be a right angled triangle. In the same way, it could also be equilateral. It's possible that all the angles are 60, because 60 plus 60 plus 60 gives us 180, which is what it needs to add up to. So yes, it could be right angled, it could be equilateral, but because we're only given one thing about the angle, in reality there could be absolutely any number of different possibilities for the other two angles. So here's just one of many I've thought of. If one's 60, the other one could be 50, the other one could be 70. That'd still add up to 180, so that's still a possible triangle. Or maybe that'd be 61, that could be 59. It really doesn't matter as long as the angles add up to 180. And so the point I'm getting at is that although it might be equilateral, or it might be right angled, it doesn't necessarily have to be either, but it could be. The second statement is a bit harder to think about. It says the triangle has at least one other acute angle. Well, we need to remember what acute means. Acute angle means less than 90. Cute. Think of it as two separate words. Cute things are normally small, like bunnies or mice or whatever. Just think of something small that's just cute, and just force in your head my point to make sense. Acute angle, it's tiny. It'll be less than 90 degrees. That's the way I remember what acute angle is. Cute, small, less than 90 degrees. So let's just imagine that this isn't true. Let's imagine that the triangle doesn't have at least one other acute angle. So let's imagine that one of them's 60, like we're told it has to be. Now, if it doesn't have another one which is acute, that means the other angles must be at least 90. So maybe the other one's 90, and maybe the other one's 90. But if we add them together, that tells us that would add up to 240 degrees, which is just impossible, because angles inside a triangle have to add up to 180 degrees. Essentially, there's no way of making a triangle work. If one's 60 degrees, one of the others has to be acute. It just has to be. These are the smallest two angles it could be without being acute, and it's still way over 180. And so one of the other ones has to be acute. So that must be true. It must be true that the triangle has at least one other acute angle. This final point here, it says the other two angles are each less than 60 degrees. Well, if they're all 60 degrees, 60 plus 60 plus 60, that makes 180 exactly. That's if it's a right angled triangle. So that would work. So one of them's got to be 60, according to the question. So if the other two are both less than 60, that can't add up to 180, it's going to be less. If the other two are exactly 60, and the first one is 60, it adds up to 180 exactly. And so if these other two here are less than 60, there's no way that can ever total 180 degrees. It's going to not add up quite to 180. So if it doesn't add up to 180, if it adds up to something less, it can't make a triangle. And so that's impossible. So if the other two angles are each less than 60 degrees, that can't be true. Because if these two were less than 60 degrees, the angle sum of the triangle would be less than 180, which is impossible because of this initial triangle fact we mentioned at the beginning. Angles inside a triangle have to add up to 180 degrees. There's no other option for it. Question 11. Multiple choice. Which of these numbers has exactly two factors? A factor is just a number that divides into the number. So I'm going to give you a working method for this one, and then I'm going to show you a calculator method for doing it. Exactly two factors. So for first of all, we can have a look at 6 and think, what numbers could we divide 6 by? Well, we can divide 6 by 1, which gives us 6, but we can also divide 6 by 2, which would give us 3. And so 6 actually has 4 factors. 1, 2, 3, and 6. 7 can only be divided by 1 and 7. 7 is the one with only 2 factors. I'm just going to show you 8 and 9, just for the sake of it. But we already should know now the answer is going to be 7. So circle the answer, we need to circle 7. Just to make it clear though, 8 can be divided by 1 and by 8, but also 8 can be divided by 2. Half of 8 is 4. And so just like with 6, 8 has 4 factors. And 9, again like anything, it can be divided by 1, which gives itself, but 9 can also be divided by 3, which again gives 3. So 3 in a way is a repeated factor because you've got it twice. 3 times 3 gives you 9. And so 9 has 3 different factors. So just as I said, the one with exactly 2 factors is going to be 7. Exactly means no more, no less. Exactly 2. So 2 factors is going to be 7. Now, I did mention a calculator tip. If a number has exactly 2 factors, that's a fancy way of saying that the number must be prime. Because a prime number has only 2 factors, itself and 1, where itself and 1 are different numbers. So which of these numbers has exactly 2 factors? It's the same as saying which of these numbers is a prime number. It's exactly the same thing. So 7 is a prime number, but I'm going to show you how a calculator can help you determine if a number is prime or not. Now, calculators now, if you get the right one, are able to do the prime factor decomposition of a number. So for example, with 6, if we type in 6, press equals, we get 6. Then if we do shift and fact, this button here, it tells us 2 and 3. So the prime factor decomposition, or 6 written as a list of its prime factors, is 2 times 3. If you try 8, press 8 equals, then do shift fact. 8 is 2 times 2 times 2. So 8 changes to 2 cubed. If we try 9, shift fact again, 9 can be written as 3 times 3, 3 squared. So if you notice, each number changes how it looks if it's not prime. But if a number's prime, if we type in a number and do shift fact, it doesn't change at all. Now, if a calculator doesn't change the number for us, that means that the number must already be prime. So that's how you can use a calculator to check if a number is prime or not. So because 7's prime, 7 has exactly 2 factors, therefore 7 is the one we need to circle. Question 12. Work out the square root of 7.5 squared plus 18 squared. Now I'm just going to explain this a bit carefully if your calculator is different to the one I'm showing you. If you notice, this square root here includes everything underneath it. So it's a square root of 7.5 squared and of 18 squared. And so what we need to do here is to do 7.5 squared plus 18 squared and then square root it. So it's asking us for the square root of 380.25. Because that bit underneath the square root is 380.25. Then finally, if we do the square root of that, square root of 380.25, get 19.5. So that's the one we need to circle. I'm now going to show you how you can do it directly with a decent calculator. So using this calculator here, we can just type it in exactly how it looks in the question. So type the square root symbol, which is this one. Then we can type it in, so our calculator display mimics exactly the question. So 7.5 squared plus 18 squared. So the calculator display is exactly as the question needs to be and as the question appears. Press equals and it will do it for you in one step. And so if you're fortunate enough to have got yourself a decent calculator, it really does make life much easier for you in the exam. Assuming, of course, you've taken the time and effort to learn how to use your calculator properly. Question 13. Use your calculator to work out the exact value of 18,953 multiplied by 437 divided by 11. So I'm just going to type this in exactly as it appears on the calculator. 18,953 multiplied by 437 divided by 11. So the calculator display is exactly as the question appears. Press equals, you should get 752,951. That's our final answer for part A. 752,951. So I'm just going to write this down here for part B. So we had from part A 752,951. For part B, it says use approximations to one significant figure to check if your answer to part A is sensible. Now what I've done here is I've just wrote down what we had for part A. And we're going to just round each number to one significant figure. And so at the moment, we've got three different values, 18,953. We've got 437 and we've got 11. One significant figure means we want to keep the first non-zero number in each of these values. So the first significant figure in 18,953 is the 1. So we're going to round it to this 1. So the 1 can either stay as it is or it might round up. So have a look what's next to the 1. Next to the 1 is an 8. Remember, if it's 5 or more, we round up. So the 1 is going to round up to 2. So in the case of this number, rounding to the nearest significant figure means rounding to the nearest 10,000. And so this number is going to become 20,000 after rounding it to one significant figure. After you've rounded the first significant figure, all the other numbers, if needed, just become zeros. So if it's a whole number, all the other numbers after you've rounded the significant figures in question change to a 0. So we had 4 digits after the 1, so 4 digits here have become 0. Now we look at 437. The first significant figure in 437 is for 4. That 4 represents 400, and so what this means, if we round it to one significant figure, we're going to be rounding 437 to the nearest 100. So again, we can have a look at what's next to the 4. Next to the 4 is a 3. And so in this case, we're not going to round up because 3 isn't 5 or higher. So 437 is going to become 400. Or thinking about it in the way I mentioned earlier, 437 rounded to the nearest 100 is 400. And this one here, 11, we're going to round to the nearest one significant figure. So we're going to round it according to this number here, which represents 10. So rounding 11 to the nearest 10, that one will just become 10. And so now what we're going to do is we're going to do the calculation with these rounded figures. The idea of rounding is making a calculation so straightforward that you don't need a calculator to do it. But of course, because we do have a calculator in this paper, you can, if you like, you can cheat basically. So 20,000, I'm joking when I say cheat, it's not really a cheat because you're allowed to use your calculator. 20,000 times 400 divided by 10. And we get 800,000. So using the rounded figures, we get 800,000. I'll just rub off that little mark because it looks like a decimal, which could make it completely wrong. Anyway, 800,000 is what we get. So if we compare our rounded value to what we had from part A, we can make a comment to say if the answer from part A is sensible. And the answer is yes, our answer is sensible, or yes, my answer was sensible. So it does say check if it's sensible, so you need to answer yes or no. But if you think about it, it's a calculator paper, so the only way you'd get your answer from part A not being sensible is if you've messed up your calculation on your calculator. So your answer's going to have to be yes, really, unless either you've made a massive mistake on your calculator or the question has got a mistake in it deliberately. Neither of those is true, therefore your answer's going to be sensible. Comparing it here though, you can hopefully see that it's sensible because 752,000 isn't really that far off 800,000. For example, if you were to round 752,000 to the nearest 100,000, it would be almost 800,000. So they aren't too dissimilar. They're both very big numbers, both of them either equal or not too far away from 800,000. So yes, your answer is definitely going to be sensible. Question 14 is about Chris, who sells lawnmowers, and the table shows the number of lawnmowers he sold each quarter for 3 years. Quarter means just times of the year, so there's 4 quarters in each year. So what we need to do first of all, using this table, is to have a look at the different years. So we've got 2016, 2015, 2014. For part A, we're asked in which year did he sell the most lawnmowers? You must show your working. And so we're told information about 3 different years. And so for 2016, he sold 17 plus 64 plus 50 plus 5. So if you add up all these for 2016, 17 plus 64 plus 50 plus 5 comes to 136. So he sold 136 lawnmowers in 2016. So our working is evidence is shown by us just getting the correct total. So just adding them all together. For 2015, 9 1/4 1, then 72, 61, and only 1 in the 4th quarter. So if we add together these and see what we get, then for 2015, 9 plus 72 plus 61 plus 1, 143. So that's a bit more. So we sold 143 in 2015. And then we just need to do the same thing for 2014. So add them all together. So we've got 19, 58, 53 and 2 to add up. So if we add up all these and see what we get, then we'll have our final answer one way or another. So 19 plus 58 plus 53 plus 2 comes to a combined total of 132 in the year 2014. So the question's asking us, in what year did you sell most lawnmowers? And so it's just a case of which one of these totals is biggest. So obviously it's going to be biggest, according to this, for the year 2015. That's the biggest total. So 2015 is the year, out of the years we've been shown, where he sold the most lawnmowers. So that's our answer for part A. Part B, he's using the table to decide the number of lawnmowers to stock each quarter. So at the start of which quarter should Chris stock the most lawnmowers? Circle your answer. Now, obviously it looks like the quarters are varying from time to time, but definitely quarter 4 seems to be the quietest for each year. So quarter 4, he only ever sells 8, so he doesn't need to stock too many for quarter 4. So what you could do here is just add up the total sold for each quarter to see which quarter is the busiest for sales, if you like. So the first quarter, across those 3 years, not 16, sorry, that's 19. 17 plus 9 plus 19. He sold 45 for those 3 quarter ones. Quarter 2, much busier. That's 64 plus 72 plus 58. In quarter 2, he sells a total of 194 across the 3 years. And for the third quarter, 50 plus 61 plus 53, 164. Also, if you have a look at it, for each year, the second quarter is always the busiest. So in terms of stocking lawnmowers, stock means buying them in ready to sell. You should be most prepared for having a busiest quarter in quarter 2. Because from this table, the evidence points towards quarter 2 being the quarter which has more demand for lawnmowers. So it needs to stock up ready for quarter 2 more than any other. Question 15 revolves around a test with 2 different sections. So this test, we've got section A, which has 80 marks, and section B, that's got 120 marks. So the total number of marks combined is 200. So it says Riya scores 55% in section A and 70% in section B. We need to take these different sections separately. So section A is out of 80, and she scores 55% in section A. So let's work out what she gets in section A. So for section A, she gets 55%, which means 55 out of 100. 55% of the 80 marks available. So if we calculate this, 55 over 100 multiplied by 80, what we have is 44. So for section A, she scores 44 marks. We then need to do the same idea for section B to find out the total number of marks she scores in that second section. So for section B, we're told two things. We're told it's out of 120. We're also told that she scores 70% in that section. So 70% means 70 out of 100. So 70% of 120 means this percentage of 120, which we can work out on a calculator directly. 70% means 70 out of 100. Oops. Multiplied by 120, and that comes to a total of 84 marks. So section B, she scores 84 marks. So from that we can work out her total on the paper. So Riya's test total equals 44 plus 84, which tells us the total. So add on the two scores, that tells us she gets a total score of 128 marks. From here, there's two ways of proving the answer. The answer's going to be either a yes, she does pass, or no, she doesn't. So one way we can proceed now is thinking, what percentage does she get? So we can work out her percentage as one method by taking what she got as a fraction. She scored 128 out of a total of 200. And to change from a fraction to a percentage, we multiply by 100. And so that can calculate for us what percentage score she got. And so 128 out of 200 multiply that by 100, and that tells us that she scored 64%. But what did she need to pass? She needed 65% to pass. So if she got 64%, she needed 65. So she's 1% short, and so you can say no, she didn't pass. A different way of proving the same thing would be to work out what 65% would be as a score. 65% on this test would be 65% of the total points for the test, which should be 200. So 65% of 200 would tell us how many marks she needed. So 65% of 200 is 130 marks. And so one way you can prove it is to say she needed 130 marks and she only got 128. So you could say she was 2 marks short, or doing it with the percentage method, she was 1 percentage short. So either which way you prove it, it's the same conclusion. Does she pass? Answer, no. But obviously you need to show the working so that you're just proving to the examiner, you're not just guessing if it's a yes or a no. And so this is you working out to prove that actually no, she doesn't pass the test. But hopefully she can have another go. Question 16. We've got a wheel made from a circular rim and 8 spokes as shown. The length of each spoke is 37 centimeters, and we need to work out the total length of the rim and the spokes. There's two different parts to this question. So first of all, what it's saying is this circular rim. So the circular rim just means all the way around the outside of the circle. So I'm just going to highlight the rim part. The rim is just the outside part, which is circular, as it says. So that's the circular rim. The second thing it's mentioning is the 8 spokes. 8 spokes, so we need to count 8 of them. What it must mean is the lines from the middle going to the outside. So I'm just going to highlight in the 8 spokes here. That's 4, 5, 6, 7, 8. So 8 different spokes of a circular rim. And so what we need to work out here is the total length of a rim and the spokes. So probably the easiest thing to work out first is the total length of the spokes. Now the spokes, there's 8 of them, and each of the spokes are 37 centimetres. So the total length of the spokes is going to be 8 multiplied by 37, which we can do on the calculator. And we get 296. So the total length of the spokes on their own is 296 centimetres. Now the circular rim, the rim is the total length all the way around the outside of a circle. So the rim actually means the circumference of a circle. Circumference just means the perimeter of a circle. It's the length all the way around the outside, which is what the rim is. So now we need to remember the formula for the circumference of a circle. So it's going to relate to pies, so you can relate it to food pies if you'd like. So the way I remember it is C stands for chicken pies, which are delicious. Chicken pies delicious. Apple pies are 2. So those are the 2 main formulas relating to a circle. So the second one, A, stands for area. C, which is what we're wanting to use, stands for circumference, which is the rim. So what we need to work out here as well is the diameter of a circle. Now the diameter means all the way from one end to the other. And so in this case, what the diameter will be is the length all the way from end to end, which in terms of these spokes, one spoke here plus another spoke there. So the diameter is the length of 2 spokes end to end. So each spoke is 37 centimetres long. So 2 spokes be 37 plus 37, or just 37 times 2, which should be 74. And so that's allowed us to work out what the diameter must be. Diameter of the circle is 74. So returning to what we're wanting to work out for circumference, the circumference is just pi multiplied by the diameter, which is pi multiplied by 74, because as we've just worked out, the diameter is 74. So now we can just do this on our calculator. So find the pi button. On this calculator it's above the x, 10x. So shift to get pi, multiplied by 74, and that's the result in terms of pi. We don't want the answer in terms of pi, we're wanting a numerical value. So what we do is press this button here, and it will change it to a numerical value. If you're not sure how much to round it to, just put down what your calculator says. If you are comfortable rounding it, this could be rounded to either the whole number, 232, or to one decimal place, which is what I'm going to choose to round mine to. So 232 point, and this 4 would round up to a 5, because next to the 4 is a 7, so you round it up. And so that's going to be 232.5 centimetres. And so we worked out the rim, which is the same thing as saying it's the circumference, which to one decimal place is 232.5. So now the total length of the rim and the spokes is going to be 232.5, or whatever you rounded it off to, plus 296, which comes to 528.5. So we can write this down here. Total mistake there. Did you spot it? Oh well, never mind. So the total length is the rim, which is 232.5, added to the spoke length total, which is 296, and as we said, we get 528.5. So that's our final answer for question 16. So we've got the rim added to the spokes. That's all we need to do. On question 17, we've been given a formula converting from Celsius to Fahrenheit. So it says F is the number of degrees Fahrenheit and C is the number of degrees Celsius, which you may have been able to guess. The first part is to show that minus 40 degrees Celsius is the same as minus 40 degrees Fahrenheit. So we can do this here with a simple substitution. And so what I'd say, just write down when C equals minus 40, so we can just substitute that into the formula. F equals 1.8 multiplied by minus 40, because we're saying that C is minus 40 now. So if C were minus 40, then 1.8C means 1.8 multiplied by minus 40, and then of course plus 32 afterwards. So if we type this into our calculator and see what we get, (1.8) multiplied by minus 40 plus 32 equals minus 40. And so when we use C equals minus 40 in our calculation, F comes out to be exactly the same thing. So we can just say that. So when C equals minus 40, F equals minus 40 as well. And that's all we need to do to prove it, really. Part B, again we've got the same formula. It's saying that Nick is saying because the temperature is negative in Celsius, Nick's saying because the temperature is minus 15 degrees, it must be negative in Fahrenheit. Is he correct? Show you working. Well, the easiest thing for this one is to just substitute in, instead of minus 40 for C, substitute in that C is minus 15 and see what it says. So when C is minus 15, F is yet again 1.8 multiplied by the temperature in Celsius, in this case now minus 15, plus 32. So if we just type this into our calculator and see what we get, 1.8 multiplied by minus 15 plus 32, that equals 5. And 5, last time I checked, isn't negative. And so it is possible, this proves, to have a negative value for degrees Celsius, but the temperature in Fahrenheit can be positive. And so, basically, Nick is wrong. Is he correct? No. But you need to show a calculation or working to prove it. And the easiest way of proving it is just to substitute in C equals minus 15 degrees Celsius. Question 18. I'm going to do this question two different ways. The first method, I'm actually going to give credit to my students. A lot of my students have used this method, so I thought, well, I'll just do it the way you guys have been doing it. And it's worked. Anyway, you've got 5 cards, one of the cards is removed, and the mean of the numbers on the remaining 4 cards, is 6. Which card was removed? So, a lot of students' work I've marked, having done this question, was using a trial and improvement method, just trial and error. Just trying different cards. So it goes something like this. There's only a certain number of cards it could be, so it's not going to take us ages if we do use this trial and error method. So if one was removed, the mean, just imagine one being removed, the mean of the numbers that would be left would be the total of all the numbers divided by how many numbers are left. Remember, the mean is always a total of values divided by the number of values. So if I add these numbers together, 5 plus 7 plus 9 plus 11, and then we divide that by 4, we'd get 8. But it says the mean of the other cards must be 6. So 8 is definitely not 6. So it can't be the one that was removed, because removing one just doesn't work. So we've tried that, it's not worked, never mind, but let's put one back in and try a different card. Maybe the 5 was removed. So let's try if 5 was removed. So if 5 was removed, let's just get rid of the 5. Bye-bye. So the mean, if 5 was removed, would be the total of the remaining cards, 1 plus 7 plus 9 plus 11, divided by the number of values we've got left, which again is 4, because that leaves 4 cards. So if we add all these numbers together, so in fact we can just edit this if you'd like. So 11 and 9 are still there, as is 7, but the 5 is replaced with a 1. Press equals, we get 7. And 7, yet again, it isn't 6, which it needs to be. So removing 5 didn't work either. But never mind, let's keep trying. So 1 was removed, didn't work. We've tried 5, that didn't work. So maybe we can remove 7. So let's remove 7. If 7 was removed, it's not exactly the most dynamic way of doing the question, but it will work, because only so many cards it could be. So the mean, if 7 was removed, let's get rid of 7. The mean would be 1 plus 5 plus 9 plus 11. All of that divided by 4. So let's calculate this one. So we've got, just move this over for a second. 1 add 5 add 9 add 11 divided by 4 is 6.5. And again, 6.5 isn't 6. So surely it's going to be either 9 or 11. So let's try if 9 was removed. So put back the 7. We're going to try 9 next. So if 9 was removed, then the mean would be the total of the remaining cards. So say bye-bye to number 9. The cards that are left are 1 plus 5 plus 7 plus 11 divided again by 4. So let's try this. So we've got 1, 5, 7 plus 11 divided by 4. That does give us 6. So therefore, 9 was removed. I'm now going to show you my method. I'd show you my method first if only this method hadn't proven so popular with students have seen. So since you'll be students watching it, by and large, that's why I've used that method, because it might speak more to you guys. It doesn't really matter which method you understand, as long as you understand a method which is right for you. And so that's one method. I'm now going to explain a different method. So same question yet again, on a clean page. Just remember what the mean is. The mean is the total of values divided by the number of values. And so if we just take this formula and put into it what we know. So we're told that the mean has to be 6. So 6, which is what the mean must be, is the total of all values. Let's just call the total t for total, divided by the number of values we've got. It does say what the total of the cards left is. We've got 4 cards left. So the number of values left after we remove one of the 5 cards would be 4. So now it's an equation and we're trying to find out what t is. So t is being divided by 4. To work out what t is on its own, we've about 4 in the way. We can swap the 4 over. But if we swap the side, we swap the sign. Opposite of dividing by 4 is multiplying by 4. And so t will equal 6 times 4, which is 24. So the total of the remaining cards must be 24. So then what you can do is just think, well, what card's been removed? So the total of all of these cards together total of all cards we can just add together all the cards' values. So 1 plus 5 plus 7 plus 9 plus 11. The total of all the cards is 33. After one of the cards is removed, the total is then 24. So which card was removed? It'll be the difference between all the 5 cards, take away the 4 cards which we are left with. So 33 take away 24 gives us 9. So that's how I'd do it. You guys listening to the video may think differently. So as long as you can understand the answer is 9, we're all good. Question 19. We have to divide 120 into the ratio 1 to 4. And so what we have to do for this one is to think of 120 split into two different things. So we're going to divide 120, one lot here, 4 lots here. One lot plus 4 lot gives us a total of 5 lots. 120, we're talking about the total here, so we can do this method. So all these lots, 1, 2, 3, 4, 5, must total up to 120. You can work out the size of each lot by doing 120 divided by 5, because we're splitting 120 into 5 equal bits. 1 bit here, 4 bits here. And that tells us that each piece, each share, each lot, whichever word you want to use for it, is worth 24. And so each lot is worth 24. So one lot of 24 is 24. The other 4 lots of 24 is the same as 24 multiplied by 4, which will come to 96. And so the final answer for part A is 24.96. Part B, we're told to write the ratio 7.4 in the form n.1. These questions are, relatively speaking, rare, but they can come up as it's come up here. So what we need to do is compare the first number. First number here is 7. The first number here is an n. And the final number used to be a 4. Now it's a 1. What I recommend you do is to write the original ratio directly above the new one. So we want to write it in this form n.1. What I'm suggesting now is you have a look at whichever number which is changed to a 1. So the 4 has become a 1. 4's the last number, 1's the last number, so the 4 relates to the 1. Just be thinking, what do I do to 4 to make it 1? In particular, what can I divide 4 by to make it 1? Well, any number divided by itself will equal 1. And so that 4 must have been divided by 4. N just means whatever the hell it needs to be. So if we do something to one side of a ratio, to keep the balance the same, we need to do the same to the other side. So n will just be whatever 7 divided by 4 is. If we divide the 4 by 4 to get the 1, which it needs to be, we need to do the same to the 7. And so n is 7 divided by 4, which you can work out here. 7 divided by 4, which is 1.75. So n is 1.75. Obviously 1 is 1. So that's 7.4 written in the correct form of n.1. In this case, n would have to be 1.75. And 1 is obviously just 1. And that's question 19 done. Question 20. In my humble opinion, this is probably the hardest question on the entire paper. What I think makes it so hard is because we've got different time frames. So if you have a look here, first of all, 2015 and 2016, they're years. When mentioning a wage per month, Then it says per week, and then hours. So there's 4 different time frames we're talking about. What I would suggest is tackling it step by step as follows. So first of all, in 2015, he was paid £1,350 per month. In 2016, we're told that he has a 2% increase in his monthly pay. And so the increase will be 2%, which means 2 over 100. So that's going to be an increase of his old monthly pay, which is £1,350. So the increase in wage is 2% of 1,350, which we can work out directly. £27. So the new wage because it's an increase, we add this on to the original. So the new monthly wage is the old monthly wage, which is £1,350, plus the £27 increase, which gives us 1,377 per month. So that gives us a total. What I'm suggesting now is we could work it out per year. Now this amount per month we can multiply by 12 to find out the yearly pay now. So add on 1,350 like I said from before, we get this figure. Multiply it by 12, £16,524. And that's for the year 2016 total pay. Now we need to look at how long he's worked. So if he works 37.5 hours a week, but in 2016 he's worked for 47 weeks, you might be thinking, well, there's 52 weeks in a year. Bear in mind you'll take some time off for holidays and Christmas and whatnot. And so the total hours he's worked, we can work out from this information. In 2016, the total hours he's worked, 37.5 hours per week, multiplied by the number of weeks he's been working, which is 47. We get a grand total number of hours worked of 1762.5. And so he's worked that many hours in total for 2016, and he's got that much pay. And so what we can say is he's been paid that much money for that many hours in total. But the question here, we want to work out the total pay per hour. Now pay per hour means you want to work out how much you get paid, not for all those hours, but just for 1 hour. So what can we do to 1762.5 to bring it down to exactly 1? Now as I've mentioned before, in class and in this video in fact, we can divide any number by itself to get 1. So what we can do is divide by 1762.5. However, if we divide this side of the relationship by this number, we'll need to do the same to the other side, in this case the total wage. So divide both numbers by 1762.5, and that will tell us his hourly wage. So 16524 divided by 1762.5, we should get a very awkward number which doesn't look like money. It'll look like money if we round it to 2 decimal places. In other words, we can round this to the nearest penny. So it's £9, 37 pence and a bit, but next to the 7 pennies is a 5. So 5 or more means we round up. So that 7 would become an 8. So to the nearest penny, that would be £9.38. So his pay per hour is £9.38, because £9.38 for 1 hour means, by its definition, £9.38 per hour. As I've said, I reckon that's probably the hardest question on the entire paper, but that's just me. But that's how you could tackle question 20. If you're not sure how to get the full marks or the full working out, the easiest thing I'd suggest, work out the 2% increase. 2% of that is 27. Add it on. You can get those first 2 marks relatively easy. So don't be panicking and writing nothing down. Do put something down on your paper. As I say, quite a tough question, that one. Question 21. We've got an experiment here that's been carried out 200 times with 3 possible outcomes, K, L and M. And we need to complete the table. So already we can see 3 missing values. To get 2 marks, we need to have these 3 missing bits filled in correctly. And so the first one I'd suggest looking at is the frequency. So if the experiment's carried out 200 times, K plus L plus M should have to equal 200. And so we've not been told the frequency for M. But what M will be whatever's left to make the frequency row total 200. So M will be 200, take away 84, take away 54. And so if we work this out, 200 minus 84 minus 54, we'll find that M should be 62. So 62 goes into this box here. We also need to fill in the relative frequencies. Now there is a formula for relative frequency, and it's simply put just a fraction of an amount. The relative frequency of an event is the actual frequency, the number of times it happens, divided by the number of times the event's repeated. Most textbooks call that number the number of trials. It just means how many times something's repeated. So if you're throwing a dice, the trials means how many times you throw the dice, for example. So the number of trials, we've been told the experiment's been repeated 200 times. And so for the relative frequency of L, that's going to be 54 over 200, which your calculator should tell you is 0.27. And the relative frequency of M is again going to be the frequency of how many times it was an M, 62, again divided by the total number of trials, which is 200. And so the calculator should tell you that's 0.31. And so those are the missing values. The three missing values were the frequency of m, which is 62, the relative frequency of L, which is 0.27. By the way, the relative frequency will always be a number between 0 and 1. And finally, the relative frequency of m we needed to work out, and that one was 0.31. And so that's part A completed. So part B, we've got the same table. I'm just going to quickly copy in the results from before, so we're looking at the same table and same results. Part B says that altogether the experiment's actually repeated 500 times. And we're asked, how many times would you expect the outcome to be a k? And so the relative frequency of the experiment being a k is 0.42. So that means that 42% of the time you'd expect it to be a k. So it's this proportion of the total we're interested in. So to work out the number of times you would expect a k, what we do is you take the relative frequency and multiply it by the total number of trials. So because this is going to be repeated 500 times, we take the relative frequency of k, 0.42, and multiply by 500. And so if we try this here, what we should get is a total of 210 for expected times that k happens. And that's therefore our final answer for question 21. Question 22, we have information about the UK and Germany, and we've even been given a formula, which is quite nice, because we don't really need to think what the formula would be, we've been told what it will be. So the population density is the population divided by the area. And so what we need to do is compare the population densities for both the UK and Germany. And so for the UK, the population is 64 million, whereas for Germany the population is 82 million. And the area of the UK, 95,000 square miles. The area of Germany apparently is 140,000 square miles, so Germany's bigger than the UK. A bit of geography there embedded into your maths. Who said maths was boring? Not me. So what we should do is just take these separately. So the UK, the population density for the UK is going to be the population of it, which is 64 million, over the area of the UK, which is 95,000 square miles. And so if we carefully type this into our calculator, and I do mean carefully, making sure we don't forget any zeros and don't add in any extra zeros by mistake, 64 million, that's right. In fact, I'll do it using the fraction button because it's how it looks in the question. So 64 million all over 95,000. Press equals. And you'd get a number which is 673 point something. It's up to you what you round it to, as long as you're rounding sensible. You could round it to 673.7, or you could round it to 674 to the nearest whole number. It doesn't matter as long as I say your rounding is still maintaining accuracy. If in doubt, just write down what your calculator tells you. So I'm going to call this roughly 674. Don't worry if you've rounded to something different, as long as your figure is very close to 674. So it shouldn't be any lower than 673, shouldn't be any higher than 674. So for the UK, that's our population density. We're now going to compare that with Germany. So for Germany, the population density is going to be the population of Germany, which is 82 million. So more people living in Germany. We're going to divide that by the area of Germany, which is 140,000. So again, we can treat this like a fraction, like we did last time, or you could do it as a straight division. Doesn't entirely matter. 0, 0, 0, 0, 0, 0. 82 million. Check I've got it right. I have. Divided by 140,000. That's one too many zeros. So take one off and press equals, and we should get for this one a number in between 585 and 586. And so what I'm going to do is round it to the nearest person and say it's about 586. 1 mark for each figure. But we are asked to make a comparison. It says compare the population densities of the UK and Germany. So what I'd suggest to do as a final step is to make a comparative sentence. Just finish off by writing a simple sentence comparing the UK and Germany. So what I'd suggest is, just by saying something along the lines of, the UK's population density is greater or is bigger than that of Germany. And that will get you your full marks. So do make a concluding comparison. Don't just leave it as two figures. You need to compare the figures for that third mark. Question 23. We've got 4 different boxes, so 5 different options we can tick. Which one of these is discrete data? Well, there are 2 main types of data. If one's discrete, the other main type of data is called continuous data. So I'm just going to give a very brief explanation of which one is. So discrete data, the simplest way of explaining this is it's countable. Whereas continuous data is data that is measurable. So discrete is countable and finite. It's usually only whole numbers. Whereas continuous is measurable. For example, you'd measure height with a tape measure. You'd measure time with a stopwatch. You'd measure weight with some weighing scales. So you can't say something's just 1 kilograms or 2 kilograms. It could be 1.5 kilo, could be 1.3, could be more or less anything. Whereas discrete data, which is countable, could be something like, for example, shoe sizes. I'm using the example of shoe sizes because a common misconception of discrete data is that it has to be a whole number. Almost always it is, almost always, but shoe sizes is discrete because there's only a certain number of shoe sizes. 1, 1.5, 2, 2.5. You couldn't have a shoe size of 2.72143, for example. So it could be shoe sizes would be discrete. Number of animals at a zoo. Things like that. And so applying that to our options, which one of these would be discrete? Which one would be countable? You wouldn't count the mass of a TV, you'd measure it. You'd measure the height of a TV mast as well. You'd have to record or measure the time taken to deliver a television, but you could theoretically count the number of televisions sold. And so for that reason, that's the one which is discrete data. So the take-home point for that one, discrete, countable, continuous is measurable. Question 24, a 3-mark question this one. It says to describe fully the single transformation that maps shape A to shape B. Triangle A, which is the big one, to triangle B. So the shape's actually shrinking. Now transformation, there's only going to be 4 different possible types of transformation. So the first type of transformation is reflection. Has the shape been reflected? No. A translation is when the shape just moves from one place to another, doesn't change size, doesn't change shape, doesn't change where around it is, it just moves. This shape has moved, but it hasn't just moved, it's changed size. There's reflection, translation, rotation. For example, if something turns the wrong way up or turns a quarter of a turn, that's not been rotated, it's still the same way up. So it's not any of these. The one it is an enlargement. The shape's been enlarged. And so that's the first thing to say. So for our first mark, we need to say it's an enlargement. Now it seems a bit daft. You can have an enlargement even if the shape has shrunk. Enlargement just means a changing of size. So it's an enlargement. And with enlargements, for the other 2 marks, we can say 2 other things about the enlargement. The second thing is each enlargement will have a scale factor, and the scale factor just tells us how many times bigger the shape ends up being compared to what it was in the first place. So for this one, if we have a look at, for example, the bottom side, the bottom side becomes quite small. The bottom side of the triangle B, is only 2 squares along. From one end to the other, it ends up being 2 squares along. Whereas if you compare that to what it was initially, 1, 2, 3, 4, 5, 6, it used to be 6 squares along. So what we can do for this one is just be thinking, what fraction of itself has the triangle become? Well, it's become 2 out of the 6 it used to be. It's only 2/6 the size it was, and that can be simplified down with a calculator or without, doesn't matter which you pick, but 2/6 is the same as 1/3. A common mistake for this question is to say that the scale factor of enlargement is 3, but a scale factor of 3 would mean that it ends up being 3 times as big. It's not been multiplied by 3, it's been divided by 3 because it's shrunk. And if you're dividing by 3, that's splitting it into 1/3. So the scale factor is 1/3. So 1 mark for enlargement. Second mark for giving the correct scale factor, which I've explained as 1/3. The third and final mark is to explain where the centre of enlargement is. Now there is a method for finding the centre of enlargement, and what we can do is use a ruler and draw straight lines through each point and its corresponding point. So for example, this point here corresponds to this point here below. So carry on the line and extend it a bit further down. This point here goes to this point over here in the smaller shape. Again, extend the line. And finally, this top point ends up going down here. Once again, extend the line. And what you'll find is that all the points end up converging. All the lines meet at a certain point, and the point where the lines all meet is the centre of enlargement, and this can be given usually as coordinates. And so this purple point here is 5 along and 1 up, and so the centre of enlargement, we can say that's 5, 1. X coordinate first, Y coordinate second. And so the centre of enlargement is 5, 1. And that's how we get our 3 marks. In enlargement, scale factor 1/3, centre of enlargement 5, 1. Question 25. We've got a graph showing information about prisms with the same volume. And for part A, we need to give one example to show the volume of these prisms is 24 cubic centimetres. Now, one is highlighted, O-N-E. So we could give loads of different examples here, but all you need is one. Now, I do feel a bit sorry for you young guys, because back in the day, in fact, only last year, the exams would have the formula of a prism in there for you. Well, they don't anymore, so you need to just know what the volume of a prism is. A prism, of course, is just any shape that has the same cross-sectional area throughout. It looks the same at the front as it does at the back. So the way I would describe the volume of a prism is it's the area of the end multiplied by the length of it. Now, the technical way of putting it is it's the area of the cross-section multiplied by the length. But I once saw a mark scheme that the great Simon Farris wrote down, and he referred to it in this way, which I think is easier to picture. And so we're told that the volume is 24 cubic centimetres. So all we need to do is to pick two values of what the area of the end may be. Now, as I say, the area of the end is just me saying the area of the cross-section in simpler language, really. And the length is the value of y for any particular point on the graph. So what I'd suggest is just pick any nice and easy point which crosses a square at a corner, so it's easy to read. And so we could go for this point here, for example, at 3 and 8. So for example, when the area is 3, the length's 8. So we could give an example which is 3 times 8, and that's 24 cm squared. So that one example would do. We've picked 3 for the area of the cross-section, multiplied it by the length. That's how you work out the volume of a prism. Area times length. 3 times 8 would give us 24. So as I say, just pick one. Just pick one point on your line. You could have picked different points. It doesn't particularly matter which one you pick. So for example, you could have picked 4 and 6, because 4 times 6 would give 24, just as 3 times 8 would as well. And even at the end here, you could have picked 12, and the area of the cross-section is 12, just reading along from there, the length would be 2. So 12 and 2, 12 times 2 is 24, 4 times 6 is 24, well, the ones we picked, 3 multiplied by 8 is 24. So I'm just showing there how you could have used more than one example. So what we went for here is 3 and 8. I'm just showing you the other ones just for the case of proving that there isn't just one correct answer for this one. Could have had 12 and 2, or like I said before, could have also had 4 and 6. Just pick one. Don't need to do them all. Part B, we're given a prism, a triangular prism in fact, and we're told that the height of a triangular cross-section is h, and that the volume of it is 24 cubic centimetres. And so we need to work out the height, h. And so the cross-section for this shape is the triangular bit here. It's a triangle at the front, and it'd look triangular at the end as well. It'd be the same shape and same size triangle at the back as it is the front. And so the area of the cross-section is the area of this triangle here. And being 4 years old again, just colouring in, trying to keep within the lines. It's such good fun. Maybe I need to grow up. Anyway, so just going back to the formula for part A, the volume is the area of the cross-section, which I'm going to stubbornly refer to as the area of the end, and multiply that by the length. That's how you find the volume. So let's just put some figures into this and let's just neaten it up slightly. So the volume, we've been told, is 24. Because, well, it just says the volume's 24. In fact, I'll use a different colour than that one. I'll do that in a purple. The volume's 24. And what we need to do is work out the area of the end. Now the end is a triangle. Because the end is triangular shape. And we need to multiply that by the length. And the length of this shape, we've been told, is 5. So all we're doing here is just putting numbers into a formula and just taking it step by step. So 24 equals area of that triangle, which we need to work out if we can, multiplied by 5. So now what we need to do is remember, how do you find the area of a triangle? Well, the area of a triangle is the base multiplied by the height, which is just h, base times height divided by 2. That's the formula for the height, sorry, the formula for the area of a triangle. And of course, that's multiplied by 5. Now luckily we are told what the base is. The base of the triangle just means how long the bottom of it is, which is 6. So 24 equals 6 multiplied by h divided by 2 and then multiplied by 5. And so now what we need to do is find out what h is, and we can proceed in one of two different ways. So what I'm going to do, I'm just going to copy down this stage and pop it over here. So I'll show you a different way you can proceed once you get to this stage. Now the first way I'd be tempted to proceed would be to try and get h on its own by just swapping over these numbers here. So for example, this 6 is multiplying the h. So this 6 we can swap over to the other side of the equation. But if we swap side, we swap sign. Opposite of multiply is divide. 24 divided by 6 is 4. So 4 equals, now we've just got h for dividing by 2 and times by 5. So that 2 again can be swapped over. Now that 2 is dividing the h. Opposite of dividing is multiply. So when we swap the side, we swap the sign to the opposite. Opposite of divide is times. So on this side we're going to have 4 multiplied by 2, which is 8, equals h divided by 5. And the final step, we're going to get rid of that 5, which is dividing the h. So yet again, swap side and swap sign. Opposite of... Oh dear. Can you spot what I've done? That's bad. Right, hold up a second. That's as easy as it is to make a mistake. That was multiplying by 5. Times by 5. So what I've done here incorrectly is I've just changed that to a divide. My apologies. But I'm going to leave this mistake in just so you show that, just so I can show that I'm far from being above making mistakes. Times in by 5. I was getting one step ahead. When we swap the side, and only when we swap the side, then we swap the sign to a divide. So h is going to equal 8 divided by 5, which we can just do now. So 8 divided by 5 is 8/5, or as a decimal, 1.6. So h equals 1.6 centimetres. Now just to show you what I was going to do over here. Now the order we multiply and divide by doesn't matter, so we can leave that h to the last if we'd like, and we can just neaten up the numbers here. So what we've got is 6 divided by 2 times 5. 6 divided by 2 times 5, which is 15. And so we can neaten this bit up to say it's 15 h's. So 24 equals 15 h's. Another way you can think of this is 6 times h is 6 h's. 6 h's divided by 2. Half of 6 h's is 3 h's. And then 3h times 5 is 15h, like we get here. And so, doing it this way, we can then just do the next part in one step. And so, what we need to do is find what 1h is. That 15 is multiplying the h. Opposite of multiplying is dividing. And so h would be 24 divided by 15, which again, you'd get 1.6. So a trickier question, I'd suggest to do this one, you substitute in values step by step and just remember the formula if you can for the area of a triangle and apply that to working out the volume of a triangular prism. Substitute in your values and do it step by step, and eventually the answer should drop out for you. But well done if you can get 1.6 for h. Question 26, we've got a ball bouncing from a height of 15 metres. And we're told some information about this ball bouncing. And so, as you can see, it starts from 15 metres, bounces once, goes back to a height of h1, bounces for a second time, returns to a second height, which again is less than the other two. Eventually the ball will just settle down and just roll along the floor. And so we're told here that h1, this one here, is 3/4 of the original height. Well, the original height just means the first height, which we're told is 15 metres, and we're also shown this on the diagram. And so, saying here, Jack expects h2 to be 3/4, so he's expecting it to be the same fraction of h1. Using all the colours of the rainbow here, highlighting. Essentially though, this question isn't too bad. We just take it step by step and we'll end up with a reasonable answer. And so first of all, h1. It says h1 is 3/4 of the original height, which is 15. And so all we're doing is just picking out the information we've already been given in the question, if we read it carefully. h1 is 3/4 of the original height, 15. So now we can just use this calculator device to work that out. So 3/4 of 15 is 11.25. And so h1 is 11.25 meters. So we can just write that down on the diagram if it helps us out. Then says what Jack's expecting. Jack's expecting h2 to be 3/4 again of whatever h1 was. Well, h1 from before was 11.25. And so he's expecting h2 to be 3/4 of what we've just found out, which is 11.25. So now it's doing the same fraction, but now of a different amount. So now we need to do 3/4 of 11.25, which is 8.4375. So if you're not sure, you can leave your calculator display as it is and just put down all of those numbers. If you want to round off, which I think would be sensible, and you do it if you feel comfortable doing it, I'd round this off to the nearest 3 significant figures. Round it to 2 decimal places. That's the same as saying round it to the nearest centimetre. I don't think Jack can be quite that accurate as what he's claiming here. So you could say it's 8.44 metres once it's rounded off. If you're not sure how to round it, or rounding makes you a bit nervous, if in doubt, just put in what it says on the calculator. So I'd say 8.44 metres personally. Now part B, it says in fact h2 is 2/3 of h1. How does this affect the answer to part A? So if h2 is actually 2/3 of h1, we can work out this directly. It'll be 2/3 of what h1 was. Now from the previous part, h1 is 11.25. And so if it was 2/3 of 11.25, h2 would be not 3/4 of it, but 2/3. Which would be 7.5 metres. So I'll change h2 to 7.5 metres now. So in terms of how does this affect the answer to part A? Well, the answer for h2 from part A was, he thought it was 8.44 metres. Actually, we found out now, it'd be 7.5 metres, which is less. So because h2 is actually smaller than what we thought in part A, that means the ball bounced lower than expected, because he thought it'd bounce higher. His h2 he thought it'd be was 8.44. In reality, it only came up to 7.5, so it bounced lower than he expected. Question 27. We've got an equation involving brackets. What we can do for the first mark is get rid of the brackets by expanding them out. Expand out brackets means multiply them. So we take what's on the outside and multiply it by what's on the inside. So first of all, we're going to do 4 multiplied by 3x, which gives us 12x. And then 4 multiplied by 2 is 8. But because it's a minus 2, we need to put in minus 8. The second bit of the equation we're just going to leave as it is, 2x minus 5. So 12x minus 8 equals 2x minus 5. Here though we've got unknowns on each side. We've got an x on the left and an x on the right. What we need to do in these circumstances is to get the x's together on the same side of the equation. In effect, what we need to do is to subtract 2x's from each side. If we take away 2x's from each side, they'd disappear from this side, and over here we'd be left with 10x. The shorthand way I think about it is it looks like we're bringing the 2x to join the 12x. But if we swap the side of the equation, we swap the sign. These 2x's aren't negative because there's no negative sign in front of them. So at the minute they're positive. Once they swap over, they'll change to the opposite of positive, which is negative. 12x take away 2x would give us 10x. We've still got the minus 8, and on the right we'd just be left with minus 5. So now all the x's are together, we want all the numbers to be together on the other side. So this minus 8 can join that minus 5. But yet again, if we swap side, we swap sign. Opposite of minus is a plus. And so 10x is going to be minus 5 plus 8. Now because it's a calculator paper, don't panic and don't try and do anything you're not comfortable with without it. So negative numbers, let your calculator take the strain. So minus 5 plus 8 gives us 3. And so if 10x equals 3, that 10 is multiplying the x. So yet again, if we swap the side and swap the sign, opposite of multiplying by 10 is dividing by 10. And so x will equal 3 divided by 10, which we can say is 3/10, or we could say as a decimal 0.3. So therefore x equals 3/10. Or if you want to, you can put 0.3 if you'd prefer. So the answer line, just put down 3/10, or as I say, 0.3 if you want to write it in decimal form. Nearly at the end of the paper now, question 28. Work out the next term of this quadratic sequence. So I can give you a explanation of what a quadratic sequence is. In a way, we don't really need to know it though for this question. But anyway, I'll tell you what it means. What it means is that the sequence isn't going up in equal steps. If the sequence goes up or down in equal steps, that's called an arithmetic sequence. This one's quadratic, which means that the steps are increasing, but the gaps of the steps is constant. So I'll just illustrate this. So from 5 to 8 is an increase of 3. From 8 to 14 is an increase of 6. From 14 to 23 is an increase of 9. Hopefully already you can see that the gaps are increasing by 3 each time. So it's not that the gaps are all 3, but the gaps themselves are going up in 3s. So what the gaps are increasing by is constant. So the next gap, 3, 6, 9, the next gap will be 12. The gaps are like the 3 times table. 3, 6, 9. Next one is 12. So this number here after 23 will be 23 plus 12, which is 35. So the answer to this one is it's got to be 35. And the last question of the entire paper, we've got a right-angled triangle and we're asked to find an angle. So what angle are we wanting to find? It's the angle X. So it's a right-angled triangle. We know 2 sides, and we're trying to find another angle. This should be screaming to us, SOHCAHTOA. It's trigonometry. So what I suggest we do first of all is label the sides. So the side opposite to the x-axis, not the x-axis, the x-angle, sorry, is called the opposite. So I'm going to call that O for opposite side. The longest side is always worth labelling. The longest side is always the side opposite to the right angle, and that's called the hypotenuse. So H for hypotenuse. And the other side, if it's not the opposite or hypotenuse, the other side's called A, which stands for adjacent. The next thing I'd recommend we do is to tick the sides we know. So in this case, we're told what the opposite side is. The opposite's 3, and the adjacent, we're told, the adjacent is 7. The hypotenuse, we don't know it, and we're not particularly bothered about it either. We don't need to work it out for the question. And so we're not bothered by the H. And so what we have been told is that the opposite is 3, and we've been told as well that the adjacent is 7. And so which one of these SOHCAHTOA triangles includes the things that we know? Well, if we know the opposite, let's just highlight where we see the O for opposite in all the triangles. And if we know the adjacent, let's just highlight all the A's we see. And so what we should find is that the triangle that offers us the most information, the triangle that's most complete and colourful, is the T triangle for tan. And so what we're going to be using here is T for tan. So we can get rid of the others and just focus on the TOA triangle. So we know the opposite, we know the adjacent. What we want to work out is the angle which relates to T. Now, because we're finding an angle, what we do is we use the shift button. That's the only time we'd need to use the shift button, is if we're finding an angle. So what I'm going to do, I'm just going to get the calculator here, put it to one side, and we do shift tan, because we're interested in the T for tan triangle. And what we're going to do is tan minus 1, it's called, inverse tan. Now on the top of the triangle, we cover up T, because we want to know the T. On the top is O. On the bottom of the triangle is A. And so we type it in the same order it appears in the magic TOA triangle. So the opposite goes on the top, because opposite's on the top of the triangle, and the adjacent goes on the bottom, because adjacent comes below O. So applying it to our triangle, the opposite side is 3, and the adjacent side is 7. And so we can just type in now tan minus 1, 3, so put a fraction button if you want, so 3 on top, 7 on the bottom, close brackets, and what you should have is 23.1985, and so on and so on. So you can round that to a sensible degree of accuracy. If you're really not sure what to round it to, just write what your calculator says. But as a very rough rule of thumb, 3 significant figures will do us. And so what we could say is we could call that 23.2. So to 3 significant figures, or 1 decimal place, angle X is approximately 23.2 degrees. And that's the last question completed. So I'm hoping you found some of those questions useful. Do feel free to leave a comment in the comments section and give me some feedback. And keep looking through the papers, keep working hard, keep attending your lessons, and never ever give up, because you can get it with lots of hard work. Thanks for listening, and I'll see you again soon.